Okay, let me go to Student View so I can see what you see. And we'll go to Assignments. So I mentioned in my previous video that I would like you to complete the doodle poll so that we can meet together. Then we have this first assignment, College Algebra Bootcamp 1. So we'll be looking at these problems, which you can download. And in this video, I'm going to give you some hints on some of the problems. I would say that in the Home tab, I do have this College Algebra text as a reference. I'm not going to be lecturing from this text. This is a source book for you in case you forget formulas or need to brush up on some topics. Probably the most important topic that you might brush up on is logarithms and exponential functions. So this can be a reference for you. The algebra that we're going to be doing is actually before college algebra. One of the main techniques that we'll be focusing on is exponent rules. So let me go ahead and look at some of these problems. Let's see, I think we have it here. All right, good. All right. So what I'm going to do is give you hints for some of these problems, and then I'll ask you to hand the problems in later this week. All right. So let's take them one by one. I'll take the first one here, and we'll look at that. All right, now, what I want to do is for you to develop facility in looking at a problem and deciding what technique to use. Now here you have this problem here, and if we need to decide how we're going to approach this problem, how do you simplify this expression? All right, now first thing you can notice, of course, is that this expression does have exponents. Another thing you can notice is that the base is always 2. So that means that you can combine these terms. You should be able to combine these terms. Now remember your exponent rules. These are rules that you have used repeatedly in your other math courses, and they should be second nature to you by now. So let's just see what they are. If you have a to the x plus y, that's equal to the a to the x times a to the y. If you have a to the xy, that's equal to a to the x to the y power. There are other rules also. If you have a to the x, b to the x, that's equal to ab to the x. Okay. And there may be some other rules that I forgot that we'll see as we go along. Now in this case you can see that 2 is a common base. So let's see. So now here you have 2 to the n plus 4. Here you have 2 times 2 to the n. Now we can actually use this rule on both of those terms. For example, this first term, 2 to the n plus 4, I could write as 2 to the n times 2 to the 4. Okay? And I should be able to combine with this one. All right. Now these pluses also work the same way. You have a to the x minus y equals a to the x over a to the y. Okay? You know that negative exponents are the same thing as dividing. All right. So you should come down to a very simple expression, and the expression should have no n. So the final expression has no n. Okay, so that's my hints on problem 1. Let's go on to problem 2. Oops, let me go down here. I need to click there so we can go. All right, now let's look at this one here. Right? So what do we have here? Here we have multiple equations. X minus y equals 12. Y minus z equals 8. X plus z equals 32. Find x squared minus z squared. Okay. Now here, let's see how we're going to attack this. If we look at this setup here, what do we have? Now algebra always has variables. In this case, we have more than one variable. So our variables are x, y, and z. X, y, and z. Okay, and we have three equations here. Okay, so we actually have three equations and three unknowns. And you have seen in previous courses methods for doing this. Now you could do this, so there's some standard methods. However, let's see if we can do things a little bit nicer here. In our final expression, there's no y. So we certainly want to eliminate the y from the other equations, right? You know that if you have multiple variables, you often want to eliminate variables. Another thing is this expression x squared minus z squared. This should be a familiar form for an expression to you, all right? This type of expression often occurs in mathematics, and it can be factored. There's x plus z times x minus z. This is called difference of squares. So you need to be familiar with this factorization, with this form. This is quite an important, as I said, it's important and common occurrence in mathematics. All right? So now look what I want to get. I want to get x plus z and I want to get x minus z. That's something that will help me. These equations here, if you remember, these are linear equations. They have the variable to a single power. This is a nonlinear expression here. This x squared minus z squared is a nonlinear expression. However, I can write this as a product of two terms here. Now I can find these two terms separately. And I'll leave that to you. One of these two expressions, x plus z, you can find directly from the information. Another term, x minus z, you can find by combining information from here. If you look at the first two equations here, you can combine them to easily get x minus z. All right, so that's my hint for problem 2. Let's move on to problem 3. Okay, here's another problem. Well, let's read it first. Here we have m is 7 to the 9th, and n is 9 to the 7th. And 63 to the 63 is m to the a times n to the b. Where a and b are integers, find a and b. All right, so let's look at this problem here. We have lots of variables. It seems quite complicated. We have the m, the n, the a, and the b. We also have some numbers, 9, 7, and 63. Now, it kind of jumps out at you that 63 is 7 times 9. So that should tell you something. All right. Now, here we have m and n. Here we have m to the a, n to the b. Now, a very clear first step here. In some ways, math is like chess. You have opening moves. Very clear opening move here is just do substitution. Right. Here we have this m here, we can substitute that in here. And this n here, we can substitute in there. And then, I think from there, you're going to be using your exponent rules. And that will take you to where you want to go. All right, so that's my hint for number 3. Let's go on to number 4. All right, here we go. All right, now, in this problem, you have to deal with absolute values. Okay, so here we have a expression here, b is less than a, which is less than 0, which is less than c, which is less than 1. Now notice from this information here that B and A are negative, C is positive, okay. And then you need to find this expression involving absolute values. Now we remember the meaning for absolute value. The absolute value of some expression x can take two values depending on the sign of x. It's equal to x if x is greater than or equal to 0. It's equal to minus x if x is less than 0. All right? Now, here we have absolute value of a plus b. That's equal to a plus b if a plus b is greater than 0, or greater than or equal to 0, and it's negative a minus b if a plus b is less than 0. All right? Now, what we need to do is be able to, can we decide from this information, is a plus b positive or negative? All right. Now we should be able to decide that from this information here. Right? If you can decide which result it is, then you can decide which expression to replace absolute value of a plus b with. Okay. So then you need to replace absolute a plus b accordingly. All right? All right. And you can do this with all of the expressions, or do this with all the terms in the expression. All right, good. All right, so let's do one more. All right, then we have number 5. All right. Actually, I think I'll do 2 more because these will not take very long. All right. Now here we have some expression a plus b equals 9 and ab. We want to find a squared minus b squared. Now we notice this familiar expression a squared minus b squared again. Right? So here you have difference of squares. You can certainly take advantage of that. Okay. All right, now you could just go ahead and solve this directly using a quadratic formula. You can use substitution. Okay, all right. By substitution, what do I mean? Well, here from this first expression here, a plus b equals 9, you can use that. You can use these two together. And substitute one variable from the first equation into the second equation. And then you'll get a quadratic equation which you can solve. I think I'll leave it like that. There are other ways to do this, but that's a nice way. All right? So let's look at number 6. Number 6, I don't even think I'll need to show on this screen. It should be pretty clear. Here, this also looks like a straightforward substitution. So if we look at the different techniques that we've used in these problems, exponent rules have figured importantly. Difference of squares, that's something you should recognize. Substitution, and absolute value. All right? So we will be looking at these first 7 problems. And these will be due on Wednesday. And I'll give more instructions in the Canvas page. All right? So these first 7 problems you'll hand in. I want the problems to be handed in. This is a writing intensive class, so the problem should be written in a fairly systematic way. All right? So that's good for now. Looking forward to your assignment.